Hi, grade 11s. It is rational variable expressions, day 6. We're going to look at multiplying and dividing RVEs. When multiplying rational variable expressions, it is important to remember the following. Number 1, factor. That's why we spent 3 days on it. Factor the numerators and denominators. That tells us a restriction and allows us to simplify. Number 2, divide out any factors. That are common to numerator and denominator. Number 3, multiply the numerators, then multiply the denominators, just like we do with fractions. So for multiplying rational variable expressions, the rules are the same. Multiply the tops. Over. Multiply the denominators. Write the result as a single rational expression. Lastly, importantly, list any restrictions. It is the easiest to find your restrictions from factored form. So you're going to look back up to factored form and list any restrictions by considering the bottom not equal to 0. First, 3x over 8 times 2y over 9. I don't have anything in either of the two rational variable expressions that requires factoring. They are monomials, top to bottom. So there's nothing I can divide out, so I have skipped number 1. Number 2 is I would divide out any factors that are common to the numerator and the denominator. Nothing. Except that I am allowed to cross off any factors from this numerator to that denominator. It's all good. And I see a common factor of 3 in the numerator and the denominator. When I do my multiplication, I have 1 times x times 1 times y. I have xy. And my bottom, I'm left with 4 and 3 over 12. I have written my answer as a single rational variable expression. I considered factoring. I simplified. Lastly, I need to consider restrictions. 8 nor 9 nor 12 are ever equal to 0. I don't have any restrictions. You don't have to write this. But we have no restrictions because there was never a variable on the bottom to start with. B did not, oh, there it is. Found it. There's B. 9x squared y over 4y times 12xy over 3x squared y. These are monomials top to bottom. So I don't need to factor anything, simple factoring and so on, but I am going to look for common factors from top to bottom, any top to any bottom. So first thing I see is a y here and here, and I see another one here and here. My y's are now all gone. X. I see x squared here and an x squared there, gone. My numbers. I have a 4 here, and I can divide a 4 into the 12. I see a 3 on top to bottom. I can divide 3 into the 9 and 3 here. So I am left with a 3 times 1 times 1 times 3 times x times 1. I have 9x over 1 times 1 times 1 times 1 times 1. So my answer in simplified form is 9x. However, there are some restrictions. I'm going to look back at the original question. The original question had a y in two different places, but nevertheless a y on the bottom. So one of my restrictions is y can never be 0. I also had an x squared on the bottom. If x squared can never be 0, then x cannot be 0. My second restriction is that x can also not be 0. C. 5y times y plus 3 over 4y times y minus 5 over y plus 3. They have already factored this for us, so we don't have to do the factoring. But we are going to consider common factors from top to bottom. I see this factor in the numerator and in the denominator, and I see a y in the denominator and the numerator, and I don't see anything else that I can divide out. So I am left with a 5 times 1 times 1 times y minus 5 in the numerator, and 4 times 1 times 1 in the denominator. So in simplified form, and I wouldn't distributive law that, I would leave it the way it is. I have 5 y minus 5 over 4, or 5/4 y minus 5. But I need to list my restrictions. And the restrictions came before I divided out like factors. That leaves it more clearly what my restrictions are. This can never be 0, nor can that. So if y is 0, this becomes 0, that's a problem. So y can never be 0 from the first expression. From the second one, y plus 3 can never be 0. So that happens when y, subtract 3 from both sides, is negative 3. That's our second restriction. So the answer is 5 y minus 5 over 4, where y cannot be 0, or negative 3. D. 9x squared over 4xy times 12xy squared over 3x. Again, I don't have to do any factoring. These are written as monomials. No addition and subtraction signs is my indicator. I am looking for common factors from top to bottom. I see lots. Okay, so I'm left with x to the 1 on the top. I see a y. I can take 2, make that a 1. 12 and 4. Wow, that cleaned up. I have 9 for the numbers. I have an x left there and a y left there. Over. Gone, 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 gone. I have nothing left on the bottom. 9xy. Being careful to state my restrictions, I have looking back, I cannot have a 0 from him, or from him. So my restrictions would be x cannot be 0, y cannot be 0. And I don't need this line. There. So there's Christmas for you. E. Uh-oh. Uh-oh. As soon as I see adding and subtracting, I know that I do not have this in factored form. If I see brackets, I have it in factored form. So let's make it so. We're good at this. All right. The numerator of the first rational variable expression. I have a simple trinomial. That means I factor it like so. I have an m for my firsts, two numbers that multiply to 2 and add to 3, 2 and 1. On the bottom, I have, it almost looks like a difference of squares, but it's not. It has a greatest common factor of m times m minus 3. Fully factored, written as multiplication, I can look to divide out common factors from a top to any bottom. I'm going to factor the second one as well. The top, there's nothing I can do with that 3 minus m. We're going to play with that in a minute though. Bottom, m squared plus 7m plus 6. Another simple trinomial where we need to set up our two brackets. My firsts are m's. My two numbers are multiplies to 6, adds to 7, will be 6 and 1. This is an important point. We're going to look for our restrictions there, and we're going to look for common factors there. So, where it is right now, I am looking for common factors from the numerator to the denominator, either numerator to either denominator. M plus 1. I can divide out m plus 1 top to bottom. I don't see anything obviously, but these two are suspiciously close to each other. Both of them have an m and a 3, and both of them have a negative sign, just that the one is backwards to the other. So if I take this one and rewrite it as negative m minus 3, I have the same thing as what's below it. So I'm going to get rid of him. Now I can see a common factor from top to bottom. Wonderful. I am left with an m plus 2 when I do my multiplication. I have a negative sign and an m. Nope, he's gone, isn't he? Sorry. Okay. Bottom, I have an m and an m plus 6. I would leave it like that and not simplify it any further. It's wonderful. Remember, I have to go to the blue part again and check for restrictions because we've crossed some things off and we need to consider those as well, but they can never be 0. So I have 4 things that I see up here that could cause me problems. From my first denominator, m cannot be 0. M minus 3 cannot be 0. So m cannot be 3. From my second rational variable expression, I have m plus 6 cannot be 0. So m can't be negative 6. And m plus 1 cannot be 0. So m cannot be negative 1. If any one of those brackets were 0, we'd have a problem. So this is my final simplified form, and I need to state that m cannot be 0, 3, negative 6, or negative 1. Remember, rational variable expressions look a lot like fractions, and the rules are the same. So if we are dividing rational variable expressions, we need to use the rules of fractions. So inverting and multiplying is something we need to think about. Number 1, for rational variable expressions, we need to factor numerator and denominator, just like with multiplication. Number 2, like with fractions, we take the reciprocal of the second fraction and change division to multiplication. What we said for the last 6 years was flip and multiply, or invert and multiply. Fraction or RVE. Okay, make sure that it's the second one. The first one stays the way it is. Thirdly, then divide out common factors. Just like in multiplication, because now you have a multiplication. Do the multiplication like we do with fractions, like we did on the last 2 slides, and give your answer as a single rational variable expression. And lastly, put a little star, state the restrictions. And here's where it's weird. State the restrictions. Not just for the final answer, but for the beginning question as well. So you've got a lot of different places to look. State the restrictions for the whole journey. You can never have a 0 on the bottom. Let's do some. First one. X squared minus 4 over x plus 3 divided by x minus 2, x squared minus 9. We have suggested that you factor first. Let's do it. Because we see subtraction signs, we know that we can't cross anything off at all until we've written it as a multiplication. So the first one is a difference of squares. X plus 2, x minus 2 over that bottom, there's nothing I can do with it. X plus 3. Divide. X minus 2, nothing I can do with it. And the bottom is x plus 3, x minus 3. Be careful. The temptation right now is to try and cross out, divide out common factors. You can't do that until you flip it. So this is the place where we are going to flip. Okay. So it now becomes, leave the first one the way it was. And we're going to take the second one and flip it and make it a multiplication instead. So the x plus 3 and the x minus 3 are on the top and the x minus 2 on the bottom. Now I can look for greatest common factors from top to bottom. X minus 2, x plus 2, nope, but an x plus 3. And I am left with x plus 2 times x minus 3. And it would be fine to leave it the way it is. Now we need to consider restrictions. And this is where we need to be careful. I need to watch for zeros here and here and now here after I flipped it. So there can never be a 0 on the bottom, even when I'm the one that's doing the flipping. So from the first little star, I know that x cannot be negative 3. For the next pair, I've already taken care of him, but I need to do that one. If I had a 3 in that bracket, 3 take away 3 is 0. That's also a problem. Going to the last star, I can't have a 0 there either, and that happens when x equals 2. My answer is x plus 2 times x minus 3, where x cannot be minus 3, 3, or 2. B. X squared minus 9 over x squared minus 49, and so on. The first thing we need to do is factor. X squared minus 9 is a difference of squares. I have an x, a positive 3, and a negative 3. Same on the bottom. I have a difference of squares of x plus 7, x minus 7. Divided by, there's nothing I can do with x plus 3, although you see I like to put it in brackets, x plus 7. So when I get to restrictions, these are two places that I'm going to look. But I'm also going to do the step where I take the first one and leave it the way it is, and take my second expression and turn it upside down, so that I'm inverting and multiplying by rules of fractions. Times, turn it upside down, x plus 7 over x plus 3. This denominator also can never be a 0. Now I am looking for common factors from top to bottom. I see an x plus 3. I see an x plus 7. And I think that's it. My final answer will be x minus 3 over x minus 7, where my restrictions are from the first two brackets. I cannot have a 7 or a minus 7. In the second expression, I've already dealt with, I can't have a minus 7, but I need to also look at x plus 3 cannot be 0, where x cannot be negative 3. So, minus 5a squared over 3b squared divided by minus 10a squared b over 3b squared. There's no factoring that I can do for this one. There are no plus and minus signs within the rational variable expression. So I am, first of all, following my rules of division and inverting and multiplying. So the first one stays the same. Minus 5a squared over 3b squared. Multiply with the old denominator as a numerator and the old numerator as a denominator. I need to consider this and this, which happens to be the same, and the new flipped as points of difficulty for my restrictions. Now I'm going to look for common factors from top to bottom, and this can actually be kind of fun. A squared on the top and on the bottom. I have a b squared on the bottom and the top. I have a 3 on the bottom and the top. And I have a minus 5, so the minuses and the minuses are gone. 5 goes into 5 once and into 10 twice. So, if I can see through all of that, I have gone, 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 gone. Just a 1. Gone, gone, 2, and a b. 1 over 2b if I am correct. Yes, looks like it. I am looking for my restrictions. For this one, which is identical to the one beside it, if I had b as a 0 there, I have a 0 on the bottom. So one of my restrictions will be b cannot be 0. The other place that I need to look is right here, where I have negative 10 a squared b cannot be 0. Well, that means b cannot be 0 because I can't have a 0 here, and I can't have a 0 here. So if a squared cannot be 0, that means a itself cannot be 0. Those are my two restrictions. Last question. 21p minus 3p squared over 16p squared divided by 14 minus 9 and so on. Okay, we are going to do the factoring first and then inverting and multiplying. So 21p minus 3p squared has a greatest common factor of 3p. So I always look for a greatest common factor first. 3p times 7 take away p. On the bottom, nothing I can do with 16p squared. Let's factor. The top, 14 minus 9p plus p squared, we don't like the look of it because that's backwards to what we usually see. But the process is the same. We're undoing FOIL. This time, at the back half of my brackets, I have a p. At the front half of my brackets, I want two numbers that multiply to positive 14 and add to negative 9. The two numbers that work would be minus 7 and minus 2. So I'll write it as minus 7 plus p minus 2 plus p, and I have factored that. On the bottom, again, backwards to what we like, but the process is still the same. I'm going to do my last because I'm used to doing p and p in my brackets, so there. The 12, I need two numbers that multiply to 12 and add to 7. I want 4 and 3. Everything's positive. There. I have factored that fully. A lot of students reorder those questions before they begin factoring. It doesn't matter. Next line would be to remember that with rational variable expressions or any fractions, we would invert and multiply. So the first one stays the same. And the second fraction is inverted, and I do multiplication instead of division. I need to remember for my restrictions that I'm going to look here, and then once I've flipped it, there as well. Let's see what common factors we can find from top to bottom. 7 minus p and minus 7 plus p look strangely similar. The only difference is that one has the exact opposite signs of the other. So if I write the one on the bottom as negative times 7 take away p, I have the very same bracket. So I am going to write it like that and, getting too many colors here, cross off, dividing out common factors. I'm looking for any more that I can see. I can see a p here, so I've only got one of them now. I wish you could talk to me and tell me if you can see any more. All right, let's see. We'll see them if we've missed any. So I am left with, on the top left, a 3. And from the top right, I have 4 plus p, 3 plus p. On the bottom, I'm left with 16p. Oh, that negative sign, don't forget him, so I'm just going to put him at the front. And in brackets, minus 2 plus p. If I missed anything, it should be obvious now, and I don't see any common factors from top to bottom. So there is our simplified answer, although it may not look simplified to you, comma. I need my restrictions. So from the first denominator, I know that p cannot be 0. From my second denominator, I have two things restrictive of p. Cannot be minus 4, cannot be minus 3. I had two things I was looking for here and here. So p cannot be, well, for some that's a little bit weird. I'm not sure what to write, so let's do the work at the bottom. Minus 7 plus p equals 0 is a problem. I can't have a 0 there. So let's add 7 to both sides. Oh, there's one of my restrictions. P cannot be 7. My other one is where minus 2 plus p is 0. That's another problem. Add 2 to both sides. P is 2. Some people can see it immediately, what the restrictions are. Some of us have to do a little bit of algebra to make sure we've got it. All right, textbook, page 121, 1 to 10, and 13.